Hello, this is Theoretical Computer Science. We're doing section 1.1. We're going to do the homework problems for section 1.1. Okay? The first three problems are very simple, and then we go on to the harder problems. But we have to do them all. Okay? Before we do it, I just want to stop. Don't just watch this to see how it's done. Try to do the problems on your own, and then use me to check the answers. But if you're just going to watch me do this, it's a failure. It's just not going to work. Okay? You're not going to gain anything by doing the from the class if you don't do the homeworks. And again, I don't do the problems that are in the book. You have to do that on your own. I do the harder homework exercises, and I leave you to do the easier ones. So you're going to see every problem in the book, but you have to do it. You have to do it on your own. Okay, so assuming that you did it, and I'm begging you, stop. Do it yourself. Then see if you got it right. Okay, so here's section 1.1. First question: what is the start state? So I'm just copying exactly from the book. The start state is where the little thing points. Okay, so both of them are Q1. Okay, what is the set of accepting states? This is Q2 is an accepting state. And here Q1 is an accepting state, and Q4 is an accepting state. Okay, what sequence of states does the machine go through on input AABB? So AABB, let's follow. AABB is Q1. So we go to Q1. Okay, let's do it for here. AABB goes to AABB, goes to Q4. Okay? Okay. Does the machine accept AABB? Okay? Here, no it does not, because it ends up in Q1. Okay? And here, yes it does, because it ends in Q4. Okay? And finally, does the machine accept the string epsilon? Okay? Epsilon is the empty word. The empty word is not accepted here. The empty word is accepted here. Okay, so that gives the answer. Now I just have to say, this problem is too easy to put on a test. So we will not have such an easy problem on the test. Okay, but I mean obviously you can't do anything here unless you've done this already. Okay, great. Next. Okay. Give the formal description of the machines M1 and M2 pictured in exercise 1.1. So let's do that. Let's just remember what the formal definition is. The formal definition is M, the machine, is equal to Q, the set of states, comma, sigma, the set of letters, the transition function, Q0, the starting state, and F, the accepting state. Okay, so let's do it for each one. So this is going to be what? It's going to be the set Q1, Q2, Q3. That's the set of states. The alphabet is A, comma, B. Okay, and how do they want the transition function? Okay. Okay, I'm just going to do it like this, delta, and we'll do delta in a second. Okay, the starting state is Q1, and the accepting state is the set containing Q2. Okay, remember, the starting state is one element. The accepting state is a whole set. There's a whole set of accepting states. So that takes care of that. Let's just do delta, formally defining. Okay, this is, you have one of two letters, A and B. Make sure that you can see this. Okay, you can see this, that's good. Okay, and let's just do it. You're in Q1, you're in Q2, you're in Q3. Let's follow the rules. If you're in Q1 and you see an A, you go to Q2. If you're in Q1 and you see a B, you stay in Q1. If you're in Q2 and you see an A, you go to Q3. If you're in Q2 and you see a B, you go to Q3. If you're in Q3 and you see an A, you go to Q2. If you're in Q3 and you see a B, you go to Q1. Okay, that takes care of that. That's the entire thing. Okay, good. Let's do the next one. Q1, Q2, Q3, Q4. Okay, and the alphabet is A comma B. Transition function, we'll write the transition function in a second. The starting state is Q1, and the ending state, the accepting state is Q1 comma Q4. Okay. Okay. Now we just have to write the transition function. I don't have enough room to do it here, so I'm going to do it here. Let's do it carefully. This is the transition function. We have possible states Q1, Q2, Q3, Q4, A and B. And let's just do it. Q1, you see an A, you stay there. Q1, you see a B, you go to Q2. Q2, you see an A, you go to Q3. You see an A, you go to Q3. You see a B, you go to Q4. Q3, you see an A, you go to Q2. Q3, you see a B, you go to Q1. Q4, you see an A, you go to Q3. Q4, you see a B, you stay in Q4. Okay. Anyways, this is an extremely easy problem. You just two different ways of seeing things, and you write it out. Okay. Okay, let's move on to the next one. Problem 1.3. The formal description of a DFA is as follows, okay, where delta is given by the following table. Give the state diagram for this machine. Okay, I wrote it out. I figured it out. Okay, and the first time I wrote it out, I got it wrong, and the second time I wrote it out, and then I got it wrong. I didn't get it neat. So I'd like to do it it takes a few times to get it the right way. In other words, to make the picture as pretty as possible. But basically, the picture is as follows: Q3. And there's an up and down. Q2, Q1, and this is the deterministic finite automaton from problem 1.3. Okay, this is the starting states, bunch of ups, bunch of downs. If you draw it nicely, you get that. Okay, let's do 1.4 we're not responsible for, but 1.5, let's do 1.5. 1.5 is a bunch of finite automatons, but the main point is it's with the word not. Okay, and we know how to do it with the word not. We ignore the word not, we solve it regularly, and then in order to take care of the word not, in other words, those words not in there, what we do is we flip it. We swap. Those accepting states become non-accepting states. Non-accepting states become accepting states. So let's do it. Okay. 1.5a. Let's just read it. Each of the following languages is the complement of a simpler language. In each part, construct a DFA with a simpler language, then use it to give the state diagram of a DFA for the language given. In all parts, sigma is equal to AB. Sigma is equal to AB. Okay, and so let's do the first one. W contains the string AB. W contains the string AB. You're reading it in your thing. Let me just give you the answer because this is not a hard one. Okay, basically you start here. Okay, if you have an A, you're good. If you have a B, you're good. Okay. Okay. The hard part is, and once you have, if it contains the AB, once you have AB, you stay there no matter what. Okay. The hard part is the other things. So for example, if I'm here and I have a B, what do I do? Well, I just wait there. Okay. And if I'm here and I see an A, what do I do? Answer. I just wait there, because next I might see an A, I'm waiting for the B. And that's it. Okay? Okay. That's good for those strings that contain an AB. But what do we want? We want those strings that do not contain an AB. So what we have to do is make this not an accepting state, and this an accepting state, and this an accepting state. Okay? So the empty word is going to be accepted, a bunch of B's are going to be accepted, a bunch of B's followed by an A is going to be accepted, a bunch of B's followed by an A, a series of A's is going to be accepted, but not more. Okay? Let's do the next one. The next one is 1.5b does not contain the string BAB, the substring BABA. Okay? So it does not contain the substring BABA. Let's just do it. Okay? So basically we look for the ones that do contain BA, BA, okay? And this is, once you get it, you're happy. Again, the hard part is, what do you do with the other things? So you're here, you're looking for BABA. If you have an A, just wait there. Okay, great. If you have a B, that's fine. Now, let's say you have an A, then you go here. But let's say you have another B. Well, then you just wait there. Okay, great. Let's say you have a BA, but then you have another A. Well, then you go back here and you wait again, because BAA is not the beginning of BABA. So you have to go back again and wait for BABA. Okay? And finally you're here. If you have BABA, if you have BAB and you have another A, you go there. But if you don't have another A, if you have a BAB, then you go here. Okay? Okay, why? Because you just saw B, which is similar to that. So you saw already the beginning of a new thing, so you go B, A, B, A. Okay? That's very important where you end up. Okay? And now you do the same thing. You swap, take this is not an accepting state, and everything else becomes an accepting state. Okay, that takes care of that. Let's do C. Let's read it. Okay. 1.6c. W contains neither the substring AB nor the string BA. Okay, so it goes like this. Here's your starting state. Next, you're either going to have an A. So we're looking for a finite automaton that has AB or BA. Let's just read that. Contains neither the substring AB nor BA. So we're looking for AB. That would be like that. Or BA. That would be like that. Okay. Now, so far so good. By the way, once it contains AB, then you stay there. Once it contains BA, then you stay there. That's very good. Okay. One more thing here. let's say you have a bunch of A's. I'm sorry, you have an A, and then if you see a B, you got it. But if you just see more A's, you just stay there and wait. Let's say you're here, if you see another B, you stay there waiting for an A. Okay? Again, I'm not going to do it now, but again, this is the answer for containing AB or BA. Now you want does not contain, and so you swap it again. Accepting states and non-accepting states. You can leave. I'm going to leave that alone. You're going to do it on your own. Okay. Let's do D. Okay, let's read D. 1.5D is any string not in A star, B star. So what we want is A star, B star. Notice doesn't contain, but is A star, B star. Okay? Let's do it. It's as follows. Notice the empty word is accepted there because A star, B star could be the empty word. Okay? And if you have a bunch of A's, that's great. Okay? But you can also have a B, and then you can have a bunch of B's, and that's accepting also. Okay, so when are you not accepted? Again, look at this words. Words can start in A's, they can start in B's also. When are you not accepted? Okay, you're not accepted is if you have a bunch of A's followed by a bunch of B. Well, you can have 0 more A's followed by 0 more B's followed by something else like an A. ABA is not accepted. BA is not accepted. Okay, and so that goes to the garbage, and you stay in the garbage. Okay, and that's it. That's it. Fine, finished. Okay, let's erase this because it's getting a little bit messy. Okay, finally, let's do the last of 1.5. Okay, again, you now have to swap this in order to do it. Okay, let's just remember how we swap it. The accepting state becomes a non-accepting state. You have to rewrite it. I have a chalkboard. You have to rewrite it. Okay, and this becomes an accepting state. Okay. Okay, let's do this. Any string A, B plus star. So this is number E. A, B plus star. So what this is an A followed by 1 or more B's. Okay, let's do it. So, by the way, the empty word is accepted here because this could be a 0. So the empty word would be accepted. So what do we have? An A followed by a B followed by a lot more B's. There could be more B's. Okay, so an A followed by a B. Okay, great. A followed by 1 or more B's. Great. What happens afterwards? Well, you could get another A and you go here. If you have another A, then you can go back and get another one. More B's, more B's, more B's. Okay, but bad things can happen here also. What's a bad thing that can happen? Well, you can get a B over here. This takes you to the garbage, and you stay in the garbage. Okay? What about here? Well, I can get AA. Notice AA is not accepted. So if this is an A, that's done. Okay? And again, that's this language, but we want those things not in this language. So, for the hell of it, I'm going to rewrite it. rewrite it as follows. This is accepted. This is not accepted. Okay, this is an A, this is a B. And the garbage now becomes the accepting state. Just rewrote the same thing. Right. So this is a B, this is a B, this is an A, this is an A. This is an A comma. That's it. I just swapped the acceptings for the non-acceptings, the non-acceptings for the acceptings. Okay, great. That takes care of that. That's 1.5. Now let's do 1.6. Now remember, in class we did 1.6, the harder ones. We're going to now do the 1.6, the easier ones. 1.6a. Let's read it. Given a diagram for the following languages, in all parts the alphabet is AB, is 0, 1. 0, 1. Okay, and so we have W begins with a 1 and ends with a 0. Okay, I don't care what's going on, but it begins with a 1 and ends with a 0. Okay, so let's do this. You start here. You begin with a 1. Very good. Okay, then I want you to have a 0. Now, begins with a 1 and ends with a 0. What about if I have another 1 over here? By the way, okay, 1 second. It could have many zeros at the end. That doesn't bother me. And it can begin with a 1 and have many 1s. Okay? The hard part is, what happens if I'm here, start with a 1, it ends with a, it has a 0, a bunch of zeros, but then it has a 1 again. Well, if it has a 1 again, you better wait till you have a 0 again, because it has to end with a 0. So that's that. Okay, I'm missing something. What am I missing? What happens here when it starts with a 0? Well, if it starts with a 0, it's not allowed to start with a 0. It's supposed to start with a 1. So it goes to the garbage. And it stays in the garbage. By the way, let's write a regular expression for this. Very simple. 1, 0 or 1 star, 0. Begins with a 1 and ends with a 0. Okay, that's A. Let's do B. Let's read it. W contains at least 3 1s. This is simple. 0. I don't care how many zeros it has, but it should have at least 1 1. Then you can have more zeros, but then you have to have another 1. Then you can have more zeros. Then you can have another 1. And once you have 1, 2, 3 1s, you stay there. That's it. Okay. By the way, what does this look like in terms of regular expressions? Well, it's 0 star, 1 star, 0 star. No, sorry. Maybe I'm wrong here. I think this works. 1, 0 star, 1. Doesn't have to end at a 1. End at the 0. I'm going to put this whole thing under that. Because it could have 58 1s. Doesn't bother me. Okay, great. Let's do C. That's the answer. C. W contains the substring 0101. Okay. W contains, so this is C. W contains 0, 1, 0, 1. So we start here. I1 is 0. I1 a 1. I1 a 0. I1 a 1. Okay. Once we get that, we stay here. I can start with as many 1s as I want, as long as it contains a 0, 1, 0, 1. Okay? And let's see, what happens if I have a 0 here? Well, I just had a 0, so I stay here with a 0. Okay. These two are hard. Let's say I have, let's do this one. I saw a 0, 1, and then I'm here and I see another 1. Well, then I have to start again waiting for a 0. Ah, shoot. Waiting for a 0. So that's this. Okay. And finally, if I see 0, 1, 0, if I see 0, 1, 0, and I see a 0 again, then I should go wait for a 1. Sounds good. That's done. Okay. Oh, by the way, what's this regular expression for this? It's 0 or 1 star, 0, 1, 0, 1, 0 or 1 star. As long as it contains 0, 1, 0, 1. Okay? And this is anything and this is anything. Okay, great. Let's do D. 1.6D. Let's read it. W has length at least 3, and its third symbol is a 0. It has a length at least 3, it could be longer, but the third symbol from the beginning is a 1. So, we start here. I don't care what's over here, so I'm going to write this as follows. 0 or 1 over here. I don't care what the second symbol is, so I'm going to write that like that. The third symbol is a 1, and once we get that, I want to stay and I don't want to move. Okay? Let's write this as a regular expression. It's basically 0 or 1, 0 or 1, and then 1, and then 0 or 1 star. You can have anything afterwards. Okay, great. 1.6e. W starts with a 0 and has odd length, or very important, or, separated, or, starts with a 1 and has even length. So let's do that. Well, let's just think about it for a second. A word's going to start with something, okay? And the alphabet is 0, 1, so it's going to start with something. So let's put that like that. Okay? So that's the way we begin. Okay, let's go through this again. W starts with a 0 and has odd length. By the way, this is odd length. Just 0 by itself is odd length. Okay, it has odd length 1. Okay, so that's an accepting state. But it could have more things. Okay, it could have a 0 or a 1. We don't care what the length is. Okay, just that's not an accepting state because that would be an even number. Having a 0 followed by something else, that's not an even number. But so this is a bad state. You're not in an accepting state. But if you have another letter, anything whatsoever, That's an accepting state. Go back. So this is that parity counter again. How many times are you going back and forth? Let's just read that again. You have a 0. Starts with a 0 and an odd length. Great. What about here? It could start with a 1 and then have an even length. Okay? That's not an accepting state. Okay, I'm going to do this two ways. I don't care what happens afterwards, but that will be an accepting state. 1, 2, that's even. 1, 2, 1, 2, 3, 4, 5, 6, accepting. Okay, that works. Let me just do it one other way. Okay, this is actually a waste. Okay, you could do it this way. Same thing. Start with a 0 or 1. Okay, if you have a 0, that's an accepting state. That's not an accepting state. Okay, and if you have a 1, then what I want is an even number of things. So watch what I do. If he has one more, he's in an even number. Okay, 1, 2. Okay. And if he has 2 more, that's it, finished. Finished. Okay, that's a little bit short. That's one state less. It's a little bit shorter. That's it. Okay, so that's the homework for section 1.1. We're going to do the homework for section 1.2, and I'm going to put that up. Hope you enjoyed. I hope you did it on your own. Take care.